Hey everyone, let's talk about something that feels a bit like a physics magic trick. You've definitely felt it before. You're in a car, it's moving forward, but when the driver hits the brakes, you feel this push going the other way. Today, we're going to unpack that exact moment, a little paradox that's actually key to understanding how things move.
So here's the big question. How can you be moving in one direction while accelerating in the complete opposite one? I know, it sounds totally nuts, right? Like it just shouldn't be possible. But I promise, you stick with me for the next few minutes, and this idea isn't just going to make sense, it's going to feel completely obvious.
Okay, so to crack this puzzle, we need a couple of tools in our toolkit. And those tools are two little words, velocity and acceleration. And the absolute best way to think about them is to just picture them as arrows. Physicists have a fancy name for them, vectors, but really just think of them as arrows that tell you which way to go and how much oomph you have.
First up, velocity. Look, in everyday life, we kind of use speed and velocity like they're the same thing. But in physics, nope, they're different. Velocity isn't just about how fast you're going, that's your speed. It's also, and this is crucial, which direction you're heading. So, saying you're going 60 miles per hour, that's a speed. Saying you're going 60 miles per hour east, now that is a velocity. See the difference?
And now for the big one, acceleration. And this, my friends, is where most of us get tripped up. In physics, acceleration is any, and I mean any, change in your velocity. It's not just about mashing the gas pedal. Speeding up is acceleration. Slowing down? Yep, that's also acceleration. Even just taking a turn while keeping your speed exactly the same? You guessed it, that's acceleration too. The key word here is change. So let's boil it down. Velocity is all about the right now. It answers the question, where are you going and how fast are you getting there? But acceleration, it's like a crystal ball. It asks a totally different question. How is that velocity about to change? One tells you what is, the other tells you what's coming next. Okay, enough theory, let's get practical. Let's take these ideas and apply them to something we've all experienced, a car hitting the brakes. This is where that so-called paradox comes to life, and you'll see it's not a paradox at all. So picture this. We've got a car, just cruising along, moving to the right. That means we can draw its velocity as a big, long arrow pointing to the right. The length of the arrow shows it's got a lot of speed, and its direction is, well, to the right. So far, so good. And then, screech! The driver hits the brakes. Now, what do brakes do? They create a force that pushes against the car's motion. Since the car is moving right, that braking force is pushing it to the left. And here's the connection. That force creates an acceleration. So now we have to draw a second arrow, this one for acceleration, and it's pointing in the complete opposite direction, to the left. And there it is. That's the moment. The velocity arrow is still pointing right. The car is still moving forward. But that acceleration arrow is pointing left, fighting against it, trying to pull it back. And what's the result? The car starts to slow down. The velocity arrow gets shorter and shorter. And that's our solution. The car is moving right while accelerating left. See? Not a paradox at all. Let's just let that sink in for a second, because it's so important. The car is still moving, right? But its velocity is getting smaller and smaller because its acceleration is pointed to the left. This is the whole shebang right here. The direction of acceleration, it tells you how the velocity is changing, not which way the object is currently going. You know, the reason this whole thing can feel so weird at first is just because of how we talk. In everyday language, when we say accelerate, we pretty much only mean one thing: speed up, go faster. But in physics, the definition is so much bigger than just the gas pedal. So if you remember one thing from this entire explainer, make it this. In physics, acceleration is simply any change in velocity. That's the rule, period. Once that clicks, it honestly changes how you look at every single thing that moves. This means there are actually three ways you can accelerate in your car. One, the gas pedal. You speed up and your acceleration is in the same direction as your velocity. Easy. Two, the brake pedal. You slow down. Your acceleration is in the opposite direction of your velocity. And three, this is the sneaky one, the steering wheel. Yeah, even if you take a turn at a perfectly constant speed, you're changing your direction. And since velocity includes direction, if you change direction, you're changing velocity, which means you are accelerating. So there you have it. Thinking in terms of these arrows makes the whole braking car puzzle just make sense. You're ready. So let's put that new physics brain of yours to the test with one last little challenge. But before that final challenge, let's just say it one more time so it really sticks. The direction of acceleration does not tell you which way the object is moving. It tells you how the object's velocity is changing. All right, here we go. Final challenge. Imagine you throw a ball straight up in the air. It goes up and up and up, and then for just a split second, at the very, very top of its arc, it stops moving. My question for you is, at that exact instant, when its velocity is 0, what is the direction of its acceleration? Think about the forces acting on it. I'll let you chew on that one. Thanks for diving into this with me.